Hi, Corey Blankenship here to give you an overview of LANDFIRE biophysical settings, models, and descriptions. Let's start by defining what LANDFIRE means by biophysical setting, or BPS. You can think of a BPS as similar to historical vegetation, but here's the technical definition. A BPS is a potential vegetation concept that represents the vegetation communities that may have been dominant on the landscape before Euro-American settlement. BPS are defined based on both the current biophysical environment and an approximation of the historical disturbance regime. When we at LANDFIRE say BPS model, we really mean two things: a state in transition simulation model and an accompanying description document. Let's start with the model. We use state in transition simulation models to describe the growth and disturbance dynamics of ecosystems. As the name suggests, each model is comprised of states and transitions. A state is a development or seral stage. In LANDFIRE, we call these succession classes, or S classes for short. Here are 4 states that make up a sagebrush ecosystem. A transition can be used to represent a development or disturbance pathway. For example, the sagebrush system starts in an early seral state, grows into a mid-development state, and so on. It also includes many disturbance pathways that can cause transitions among states. We quantify the frequency of transitions by assigning each a probability. Here are the fire probabilities in the sagebrush model. You can take the reciprocal of the probability to calculate the fire return interval. LANDFIRE models are built in the SynchroSim software framework using the STSim package. Using this stochastic software, we run each model for multiple iterations and over many time steps. From the model results, we calculate the average amount of the landscape in each state and the frequency and severity of fire transitions. Each state and transition simulation model has an accompanying description document. It's exactly what it sounds like, a document that describes the model, but it has other information too. Here are some highlights. The description starts with information about who created the model. These models were created by experts across the country in collaboration with LANDFIRE. In the disturbance regimes section is this table here, which shows the frequency and severity of fire as calculated based on the model results. A critical part of the description is the succession classes section. This part describes every state in the state and transition simulation model. Here's how all the pieces fit together. This description states that Class A represents an early development all structures phase. It is described as a post-fire state dominated by herbaceous vegetation. In the mapping rules table, you can see that for mapping purposes, this state includes herbs of any height up to 70% cover. Now going to the model, you can find Class A by its label, Early Development All Structures. Double-clicking on the early development box, you see that the state age range is 0 to 18 years, and it has a fire and a wind weather stress transition. The last element of the succession class description that I want to highlight are the succession class percents. After each class letter is a number that represents the average percent of the landscape found in that class over time, as calculated from the model results. The estimated succession class amount and the fire frequency and severity recorded in the description document are what LANDFIRE collectively calls reference conditions. Okay, that was a lot of information. There are 3 things I hope you'll take away from this video. First, LANDFIRE BPS models include a state and transition simulation model and a related description document. 2, together, the model and the description describe vegetation conditions and disturbance regimes before European American settlement. And 3, LANDFIRE uses these products to estimate reference vegetation and fire regime conditions.